All right, average rate of change. Guys, average rate of change is just, it's the way to call slope if you're not talking about a linear function. All right, when we talk about a linear function, that's a line, right? Y equals mx plus b. Your slope is constant. It goes up and over from one point to the next, the same every single time, right? Does that happen when we have a parabola? Did that happen yesterday on your test when you guys had to go up? Do you go up and over to make your u? No, we have to plug in a table of values. So when they talk about the average rate of change, you're still going to use the slope formula, but it's not going to be constant. Meaning, if you look at something like this, and they ask you for the average rate of change, how fast is something going is pretty much what average rate of change is. If you notice, between this point here and this point here, or this point here and this point here, your average rate of change is different. It's not going up and over the exact same amount. Do you guys understand that? So if they ask you for the average rate of change between an interval, you would just use the slope formula. And we're going to talk about this in a little bit. But you guys do this all the time, and you're like, okay, I'm going to Halloween Horror Nights. If I leave at this time, this is how far I have to go, this is how fast I'm going to go, then we'll see how long it's going to take us, right? That's what your average rate of change is. It's just the kind of speed of things. So if we look at the average rate of change, do you guys see this is the average rate of change formula? It's the change in y over the change in x. Have you seen that before? y2 minus y1 over x2 minus x1. What you're going to do is be given a function, and they're going to give you two x values. And then you plug those x values in to find the y, and then you find the average rate of change. That's all that this is telling us to do. So let's look at this. If we want to know the average rate of change, looking at this parabola, between 1 and 3 on the x-axis. So let's look right here. First thing I'm going to look at is between 1 and 3. What's going on between 1 and 3? Is it speeding up or slowing down? How do you know it's slowing down? It's decreasing, right? So what kind of a number should we have here when we figure this out? If it's decreasing? Negative. Okay, good. Good thinking. So what you do, how we figure this out, is they're telling us between 1 and 3. So you're going to plug in where x is 1, see what you get out for y. Then we're going to plug in where x is 3 and see what we get out for y. Okay, this is how you would show me your work. This is how you figure out the average rate of change. This says f of x equals x minus 3 squared. So f of x equals x minus 3 squared. What is f of x, a fancy way of saying? Y. So we're going to plug in these x values to find our y. Yes, ma'am? How did you get x? Yeah.
Why did you square it?
Because they're telling me that the function is right here. They're giving me the function to use. Christian, question?
No, I just figured it out.
Okay. All right. So let's evaluate. Let's evaluate with 1. So if I plug in 1, I have 1 minus 3 squared. Right? We evaluate inside parentheses first. So 1 minus 3 is negative 2. And negative 2 squared is what? 4. So when I plug in 1, I get out 4. Correct? All right. Same thing we're going to do. We're going to evaluate over here with 3. So I have 3 minus 3 squared. Well, what's 3 minus 3? 0. And 0 squared is 0. So here are the 2 points, the x value and the y value, that they want me to find the average rate of change. Guys, this is my x, this is my y. This is my x, this is my y. Your average rate of change is just the slope formula, the change in y over the change in x. So I'm going to say y2 minus y1 over x2 minus x1. It matters what order you go in, and it matters that y's are on top. I'm going to start with 0 minus 4. If I say 0 minus 4, what do I need to start with on the bottom? 3 minus 1. Since I started with 0 on the top, I need to start with 3 on the bottom. So 3 minus 1. What is 0 minus 4? Negative 4. Over, what's 3 minus 1? 2. Does this simplify pretty? So your average rate of change between where x is 1 and x is 3 is negative 2. All All right, so we're going to do the next thing. We're going to evaluate the average rate of change for the function x minus 3 squared between where? Where do they want me to evaluate for b? Between 4 and 7. So what they're asking me to do is they're saying, okay, plug in x is 4, see what you get out. Plug in x is 7, see what you get out. Remember, our function is x minus 3 squared. F of x equals. Where did I get that? It was in the problem. So if I'm going to find the rate of change, the average rate of change between where x is 4 and x is 7, I have to figure out what y values I'm using. So I'm going to plug in 4, so 4 minus 3 squared. What's 4 minus 3?
1.
1, and 1 squared is?
1.
Good. Now I'm going to come over here, and I'm going to plug in 7. So I have 7 minus 3 squared. What's 7 minus 3?
4.
And 4 squared is? 16. So here's the 2 points that they want me to figure out the average rate of change. You're just figuring out how things change from one x value to the next. So I'm going to say y2 minus y1 over x2 minus x1. So I'm going to put 16 minus 1. If I say 16 minus 1, what do I have to say on the bottom? 7 minus 4. Since I started with 16 on the top, I need to start with 7 on the bottom. What is 16 minus 1? 15. And what is 7 minus 4?
3.
So what is your average rate of change between these 2 points? 15 over 3, which is 5. Do you guys notice how your average rate of change is different? It's not going to be the same like it is in slope, because slope is a linear function has a constant slope. It's the same. From one point to the next, you go up and over the same amount. Here, you're talking about a different kind of function. It could be a cubic function that has the exponent of 3. It could be a squared function that has an exponent of 2. That's a parabola. So if you notice, between 1 and 3, our average rate of change is negative because your function is doing what from those 2 points? Decreasing. Your average rate of change here between 4 and 7 is positive because it's doing what? Increasing. Question. All right, here we go. It says find the average rate of change between the following points. All right, what conclusion can you draw from your answer? I'm going to change this question a little bit. What is the average rate of change going to be between all of these points? What is your average rate of change going to be between anything that I do on this function?
How would we know?
3 and 6, is it like you
What does the function say?
3x minus 5?
3x minus 5. What kind of a function is 3x minus 5? It's a linear function, right? X to the first power, that's in y equals mx plus b. Your slope, your average rate of change is going to be what every single time?
The same.
The same. What is it? Guys, what is, if this, you're telling me this is a linear function, right? This says y equals 3x minus 5.
It's a linear function.
A line. If I asked you guys to graph this, what's the y-intercept? Negative 5. And how much do I go up and over from negative 5?
3.
I go up 3n,
Over
and then I go up 3n,
over
and then I go up 3n over 1. So your average rate of change here is constant because it's a straight line. So let's change this. Let's change our function to f of x equals 4x squared plus 3x minus 5.
Where'd you get that?
Right out of my head.
Oh.
I want to find the average rate of change between, let's do x is negative 2 and x is 1. And then we'll do it between x is 3 and x is, I don't know, 5. All right, so if you had a problem like this and I said to you guys, all right, find the average rate of change between these two intervals. Explain to me how I would do it. What would we do?
You plug in negative 2
I plug in negative 2.
for the first one and 1 for the second.
Okay, so I'm going to say, I'm going to evaluate my function at negative 2, see what my y value is. Then I'm going to evaluate my function at positive 1, see what my y value is, and then figure out the rate of change between these 2 points.
But you plug in negative 2 for the first x and 1 for the
No, for all of it. So I say Agreed?
Yeah.
Okay, so let's work left to right. PEMDAS, what do I do first?
-2.
I'm going to do -2 squared. So I have 4 times 4, right? Plus 3 times -2 minus 5.
Yeah.
What's 4 times 4? 16 minus what? 6 minus 5.
Yeah.
Now we work left to right. What's 16 minus 6?
10.
10. And 10 minus 5 is?
5.
So when I plug in -2, my y value that I get out is 5. So now I'm going to do the exact same thing. I'm going to evaluate this function where x is 1. So I have 4 times 1 squared plus 3 times 1 minus 5. Well, what is 1 squared? 1. Good. Times 4. So I have 4 plus, what's 3 times 1? 3 minus 5. What's 4 plus 3?
7.
And 7 minus 5 is
2.
2. All right, have I found the average rate of change between x is -1 and x is -2 and x is +1? No. How do I do that? y2 minus y1. My suggestion to you guys, I'm going to write the points on top of each other because it's really easy to make silly mistakes. If I miss a sign or something, is that going to negatively affect my answer? Yes. So here's my x, here's my y. y2 minus y1 over x2 minus x1. Doesn't matter which y you start with, but you have to start with the same x. So which y would you guys like to start with?
5.
Okay, so I'm going to say 5 minus 2 over what?
-2 minus 1.
-2 minus 1. Good. 5 minus 2 is 3. -2 minus 1 is -3. So what are the chances? What is the average rate of change for this function between x is -2 and x is +1? Your average rate of change is -1. I could never do that again where I just make up a function and pick 2 random points and be -1.
Can you give that other for a second?
Sure. All right, let's do the next. Let's do the next. We're going to evaluate now between x's 3 and 5. What can you guys tell me about this function? Between, guys, up here. What can you tell me about this function between -2, where x is -2 and x is +1? Just, what do you mean by it's a negative? It's decreasing between those two. Good, very good. How did we know it was decreasing? Because the average rate of change is negative. Very good, Gio.
So what would you say, the average rate of change is -1?
Yes, the average rate of change is -1. And if I asked you what the behavior of that function was between those 2 points, you would tell me it was decreasing. All right, let's come over here. Between x equals 3 and x equals 5, we're going to do the exact same thing. Now we're going to evaluate with these 2 values. So I have 4 times 3 squared plus 3 times 3 minus 5. Yeah?
Yeah.
Okay, so 3 squared is?
9.
And 4 times 9 is? 36. 3 times 3 is?
9.
What's 36 plus 9?
45.
Good, minus 5.
40.
So when I plugged in 3 here, I got out 40. You guys agree? I know, it's moving and shaking here. So now I have 4 times 5 squared plus 3 times 5 minus 5, right? Did I write that correctly? Okay, so 5 squared is 25, and 25 times 4 is 100. What's 3 times 5? 15 minus 5. So what's 100 minus 15?
What?
Sorry, I have no idea why I said that. What's 100 plus 15? 115 minus 5 is 110. So when I plug in 5, I got 110. So again, if we're going to find the average rate of change between these 2 x values, I'm going to say y2 minus y1 over x2 minus x1. So what do you want to start with?
110.
Okay, a 110 minus 40 over 5 minus 3. Well, what's 110 minus 40? 70 over 2, which is 35. So what can you tell me about the function between these 2 points?
It's increasing.
It's increasing. By a little bit? By a lot. Do you see how they are not? This is we evaluated, guys, on the same function between -2 and +1, and then between 3 and 5. Do you see how the average rate of change was very different?
Yeah.
Between right here, it was -1. Between here, it was +35. Big difference. Gio just asked if it was 0, if your average rate of change was 0. So think about this. What kind of a line has a 0 average rate of change or slope? A horizontal one, right? Yep. So that would be a constant, flat, horizontal line. Good. Very good. Question was, how do you know that something's a straight line? If I have f of x equals, and my x that they give me is to the first power, it's a linear function. So even if it was written like 3 minus 1/4 x, that's still a line. It's just not written in slope-intercept form. If we rewrote it, it would be y equals -1/4 x plus 3, where your slope would be -1/4 and your y-intercept would be 3. So whenever x is to the first power, it's a linear function. Your average rate of change would be constant. But we're not going to do that. Ours are all going to have either squared or cubed or something like that. So you'll see the average rates of change differ from time period to time period.
I was going to ask that. What if it's not to the first function?
That's what we're working on now. It's going to be different from whatever given period. Like here, you know that no matter where I pick on a graph, -2 to +3, whatever, your average rate of change is going to be the same because it's a line. From one point to the next, your average rate of change, your slope is constant. It goes up and over the same amount. That only happens for a linear function. Good questions.